video on Boyle's law. Boyle's law is another law that we're going to learn having to do with gases. So it's another gas law. Boyle's law talks about pressure and volume, P and V. So to begin with, I'd like to talk about some units of pressure. Some units of pressure are atmospheres, abbreviated ATM, kilopascals, abbreviated kPa, and millimeters of mercury, abbreviated mmHg, because Hg is the symbol for mercury. Now, we're going to have to do some pressure conversions for some of our problems. So here are some of the conversions. 1 ATM, 1 atmosphere, is equal to 760 mmHg. 1 torr is equal to 1 mmHg. So a torr and a millimeter of mercury, those two units, their scales, are the same. 1 ATM is equal to 101.3 kPa. Okay, so what if I gave you this question, and that is, how many ATMs are there in 5.0 mmHg? This is just a quick conversion. Let's identify the conversion. So I'm starting with my given, mmHg, and I'm trying to go to atmospheres. How many atmospheres? I look to see, do I have a relationship between mmHg and atmosphere? And I do, right there. There's my conversion factor. So let's begin. Remember, you always start with your given, and that is 5.0 mmHg times, same thing with our dimensional analysis setup, mmHg goes on the bottom, copy top to bottom, and we're trying to get to ATM, so the ATM goes on top. And the conversion is 1 ATM has 760 mmHg. That's it. Now all we have to do is take our 5 times 1 divided by 760, or a little shortcut, 5 divided by 760. And remember, always look at the beginning for your sig figs. Your given had 2 sig figs here, so when you solve, your answer should have 2 sig figs. Remember, this is the time where you want to pull out your calculator and solve. Put that answer down. Okay, well, let's now dive into Boyle's law. What Boyle's law says is that if you have a beaker here full of gas, so let's put some gas inside of this beaker. Okay, if we have some gas inside this beaker, and if you notice here on the side, I have something new attached. All this is a pressure gauge. It measures pressure. So think of it like a scale, 0, 1, 2, 3, 4. If I have more pressure, right, the scale would go this way. So if I have more pressure, that little gauge turns. So let's put a little gauge on there to turn it. Here's my gauge. Okay, right now as it reads, I have very low pressure, right? The arrow's pointing to the 0. Okay, now, again, Boyle's law talks about pressure and volume. Pressure and volume. So here's my plunger. And I'm going to create a very small volume. Wow, that's a small volume. How do you think that gas is going to feel inside that small volume? Well, it's going to feel very much under pressure. They're going to be constantly hitting each other. Pressure is your force per area. The force per area. So let's write that down. Pressure is force over area. Force per given area. There's a lot of force in that small area. So you know what's going to happen to my pressure gauge? That pressure is going to go up, maybe to something like 3, who knows, ATM or mmHg. Okay? So as I decreased the volume, my pressure went up. Now, what if I give this a lot more space? I decrease that pressure. Okay? So in other words, I made the space bigger. I made more volume. Well, if there's more volume, then these gas molecules have more space to expand and move around. So are they going to feel as much pressure? No. So that pressure gauge goes down. A lot less pressure, right? Maybe something like 0.5. All right? So, in other words then, if I apply less pressure, right, less pressure, then there's more volume. If I put more pressure, I'm squeezing and making that a smaller volume, okay? So as pressure increases, my volume decreases, okay? And vice versa. This is called an indirect relationship, So the equation we see for this is going to be this. Boyle's law talks about pressures and volumes. These are my initial pressure and volumes, and then it's going to change. The scenario is going to change, and something's going to happen to the gas, and it's going to have a new pressure and a new volume, okay? So let's go ahead and look at a problem. Take a second and copy that down. A sample of gas has a volume of 1.40 liters and a pressure of 225 mmHg. What will the new volume be when the pressure is increased to 510 mmHg? Well, the first thing you want to notice is that you've got a volume and a pressure that are initially stated. These two are connected. So those are my P1 and my V1, right? Let's list out those variables. Here they are. My initial volume and my initial pressure. Then something happened, and now I have a new volume and a new pressure. Those are your second conditions. So my pressure increased, here's P2 to 510, and they asked, what will the new volume be? I set that to X. So here are all my variables listed out. This is important to do. Before you begin your problems, try to list out your variables so you're organized. Next, now I'm going to solve for this problem. Okay, in order to solve, I have to bring back my equation. Okay, let's plug in my variables. Well, my P1 is 225 mmHg. My V1 is 1.40 liters equals. My P2 is 510 mmHg. And my V2 is X. So I'm going to put an X. Let me see if I can squeeze an X in there. Okay? All right. Now, what's important to note is that no matter what your units are, they just have to be the same units. Meaning, if I'm using millimeters of mercury for pressure here, it has to be the same here. If it's not, guess what? I have to convert first. But they are. So since they match, this problem's easy. And my liters, if I'm using liters here, then therefore my X is going to have to be liters. Okay? Now I'm going to solve for X, do a little algebra. I recommend doing your algebra this way. Getting X all by itself first by dividing out the 510. Okay, this way you only have to do sig figs once. Now X is equal to, and in my calculator, I multiply this by this divided by the bottom. Don't forget there was a decimal here. Okay, what units cancel out? mmHg, mmHg. And now when you multiply and divide, you go the least amount of sig figs. Because there's a decimal, that trailing zero is significant. 3 here, 3 here, 3 here. My final answer needs 3 sig figs. So this is your time to take out your calculator and calculate. Your final answer should be in liters because that's the leftover unit. That's how you calculate Boyle's law.